Bailey from Prisma Technologies here. We're out here today to go through one of the new features in the latest update of DJI Terra version 5.3, which is the ability to create thermal reconstructions. Prior to this, users could use DJI's thermal analysis tool, where they would import their data and analyze a single thermal image at a time, or they could use a third-party software to create a thermal reconstruction and analyze their temperature data that way. We're going to send up our Matrice 4T drone and capture some images using its inbuilt thermal camera. We'll then import this data into DJI Terra, process this data, and go through some of the analytical tools that are available on the new update. Our subject for today are these two demonstration houses in front of me, which are both equipped with solar panels. So this will run like a typical use case of a solar panel inspection. We can start by planning our mission on our DJI Pilot 2 app. First thing we want to do is configure our thermal infrared camera settings. So we'll select our color palette. In this case, we'll use iron red, and we need to select our gain mode. Currently, only low gain mode and high gain mode are supported for thermal reconstructions. We can adjust our temperature measurement settings, where we can change our emissivity values, our distance from target, and our environmental humidity. We now want to set up our flight route to plan our mission. So we'll select a 2D area route for this mission. We'll knock up an area around our houses with enough margin either side to ensure that we have sufficient overlap through our point of interest, which is the solar panels. Once we're happy with our area, we need to select both our wide visual light camera and our infrared thermal camera. This is because DJI Terra performs aerotriangulation on our visual light cameras and then applies an internal offset to overlay our infrared thermal images. We'll give our route a name. We'll set our GSD for our thermal infrared camera to 3 centimeters per pixel, leaving us with a route altitude of 30 meters. Turning off our elevation optimization as we don't need it for a 2D map. We'll match our safe takeoff altitude to our route altitude. In our advanced settings, it's worth pointing out that our side overlap ratio and our frontal overlap ratio are relative to our infrared thermal camera, not our visual light camera. We'll set both of these to 80. Once we're happy with that, we can save our mission and send our drone up to capture some data.
Moving to start point. Taking off. Flight mission complete.
We can now go ahead and start processing our captured data. Inside DJI Terra version 5.3, we want to create a new project and select our thermal infrared tile. Give our project a name, select our storage location, and select the images, both thermal and visible light, that we wish to reconstruct. Once our data is imported, we can then go ahead and set our process settings. We'll leave our pre-processed settings as default. In our 2D map settings, we want to select our material and emissivity values. There are 4 existing emissivity values for typical materials that you might come across conducting thermal inspections. However, you have the option to add a custom material. In this case, because we're dealing with solar panels, we will select our uncheckable general non-metallic emissivity value and our photovoltaics emissivity value of 0.85. The emissivity value that you select inside your DJI Terra will override the value that you set when capturing your data from your thermal infrared camera. Once we're happy with our settings, we can start our reconstruction. Within our thermal reconstruction, there are a number of things we can do to help us analyze our data set. We can switch between our thermal infrared reconstruction and our visual light reconstruction. We can switch between our processed emissivity values, adjust our temperature scale, and switch between different color palettes. If we enter into annotation and measurement, we can take point readings, line readings, and area readings. For line and area readings, it will note our maximum temperature, our minimum temperature, and our average temperature for the area or line created. Specifically with our point measurements, we can select a point within our reconstructed map, and DJI Terra will locate the specific thermal and visual light photos that correspond to that point. Within this, we can select points specifically in that image. Within this image, we can override a number of photo temperature measurement parameters, such as emissivity, to achieve a more accurate reading. That brings us to the end of our video. Hopefully we've been able to explain a typical or basic workflow for a thermal infrared reconstruction inside the updated DJI Terra version 5.3.